Kyle. Number 11 says, find the number halfway between the given numbers. I always like to draw a picture, Kyle, just to give myself a sense of where these numbers are on the number line. This says negative 4/25 and negative 9/50. Do you know which one of these is bigger?
Yes.
Which one's bigger?
9/50.
I don't think
no,
9. I think 4/25 is bigger because this is the same as negative 8/50. Do you agree? And since they're negatives, this is negative 9/50 and this is negative 8/50. Right? Okay. Now they want the number halfway between them. What would you do to find that?
I would double the, I would just double each fraction.
Double each fraction, numerator and denominator, right? Because we need to keep the same value. So this is going to be negative 18/100ths, and this is going to be negative 16/100ths, right? Okay. Now what?
Find the number in between.
Okay.
The 200.
Yep.
That's negative 17.
Exactly. Exactly. Because this is really just negative 8.5, right, over 100, but we can't have a decimal in our fraction. So you just multiply the top by 2 and the bottom by 2, and it gave you whole numbers. Okay? I like it. Nice job. Okay? Everybody happy? Yeah, Will.
So did you say there's going to be one like that? It'd be like...
It may say 1/4.
Okay.
It may say 1/3, and we would do that differently, wouldn't we,
Yeah.
Will? Mm-hmm. We have to find the difference between them. We'd have to divide them by 3 to find out what that 1/3 distance is, and then add it to the smaller one to get there. Okay? All right, let's look at the next one. Alex, your hand is up. Express the rational number as a fraction in simplest form. Yes, ma'am, I'm ready.
All right.
Tell me what to do.
Since the minimum's only over one number, it'd be 10n equals...
Well, wait, I don't even have n yet.
well,
N
equals-
is negative 0.283 repeating. You okay, Clay?
Yep.
283, but it's only the 3 that's repeating, right?
Right.
Okay.
So,
And because you told me, but I want to make sure it gets on the video, you said since there's only one number repeating, I multiply by what?
1 10, so it's 10n.
Just by 10. Okay, so 10n is going to equal what?
Negative 2.83.
Negative 2.83 repeating. Okay? Now, let me say something about this, Alex. Because it's negative, I know my answer is going to be negative, but I don't want to mess around with negatives inside here. Is that okay?
Yeah.
All right. So I'm actually going to, whoa, that was too much. I'm actually going to get rid of these negatives. I know my answer needs to be negative, but I'm going to work with positive decimals.
All right.
Okay. All right. Now what?
And then below that, you're going to subtract n.
All right. So let's put n below it. 0.28333. Okay. And you said you want to subtract it?
Yes.
Okay. So what do I get on the left side?
You get 9n.
9n.
and
These
then-
3's just cancel, don't they?
Mhm.
Okay. And what do I do now?
That turns into a 5, and then you carry the 1.
Turns into a 5. I mean, borrow, and now that becomes a 5. 13 minus 8 is 5. Okay, got it. And then 7 minus 2?
It's 5.
All right.
0.2.
And 2.
Then you're going to divide by 9 on both sides.
Divide by 9 on both sides. Yes, ma'am. And so now I've got
Decimal, and it'd be 255 over 900.
255 over 900. What Alex wanted to do was get rid of the decimal. So she moved it twice up here and twice down there. She multiplied by 100 on top and bottom. And now what do I need to do, Cecilia?
You have to simplify.
Okay, help me simplify them.
You can divide both by 5.
Divide both by 5, yeah. And I'm going to get 51, is that right? Over what?
Over 180.
180, okay. Is there anything that goes into those two?
There is.
There is.
Is it?
It is 3.
Okay.
Just add up the add up the digits. 5 and 1 is 6, okay.
Right.
So 3 goes into 51, what do you think?
7 times.
Not 7, but 17.
Of 17 times.
And 3 goes into 180?
60 times.
60 times. But remember, at the top, we started off with this thing being negative. So it's negative 17 over 60. And that's it. Nice. What if there had been 2 digits repeating? What if 2 of the digits were repeating, Morgan?
What if I had to multiply by 100?
Multiply by 100. Exactly. That's what gets those digits lined up so that when we subtract them, they all cancel out. Okay? That's the key. Okay. Find the indicated square root. You know, the thing is, the thing that I think are good about exams is that it shows you all the things that you've learned. This stuff is easy. Now, it wasn't when you learned it, but now when you go back and look at it, this is a lot easier than it was the first time you saw it. All right? Miles, what do you do here?
Okay, so I see that 132 is 4 times 33.
Okay, well, let's do this. They want us to simplify
Yeah,
the square root of this fraction.
33 over 132. So that's the square root of
So now how do I want to rewrite this?
plus minus
Plus minus,
square root 33.
Square root
Yeah,
33.
Over square root 33.
all right, now I like that, okay? We break that apart. Now we deal with each one of
Let's do,
them
like,
individually.
I guess prime factorization.
For which one?
For square root 132. It's
All right, so
30.
Miles wants to do the prime factorization of root 132.
Yeah. That's 4.
Root 4 times root
33.
33.
Root 4 is 2. So
Oh.
it's 2 root 33.
Man, okay. All right.
Here's
So this is 2
root 30.
root 33.
And the other one's just root 33, so write that fraction.
So now I've got plus or minus the square root of 33 over 2 times the square root of 33.
Root 33 is cancelled. Or root 33. Oh, and the other.
Now before we go too fast, because we're trying to explain this, okay?
Let's multiply by root 33.
Hang on, Miles. I don't like having a square root in the denominator, okay? We would like to rationalize it. But because the square root's also in the numerator, we can just cancel them out, and that's what Miles was saying. So this turns into plus or minus 1 over 2. Okay?
I thought it would just be 0 at the top.
No, when you're canceling, it leaves a 1 there, right? Okay? We could have multiplied this by root 33 and root 33, but then we're just going to get 33 over 66 on the bottom because it's 2 times 33. And that's going to bring us back to plus or minus 1/2. Yeah, well, okay.
And I believe it would be a lot harder, but you could multiply by 132 on
You mean right here?
Yeah.
Multiply, rationalize first? Yeah, I'm going to get
It's
this thing
fine.
as simple as possible because those numbers get really big. So you got 132. Don't tell me. You got, let's see. Am I right so far? You got 4,356? And the square root of that is 66. And then that reduced to 1/2. All right. That's big numbers though, okay. But it works, right? All right. There are lots of different ways to get to Waxahachie. Okay. Let's look at the next one. Morgan, take us through this one. What do we do?
Okay, I did prime factor of 600.
5 times root 600, and you want to prime factor this into what?
I did 2 and 300.
All right, so 5 times root 2 times root 300. Okay, now what?
And then 2 and 150.
All right, so 5 root, 5 root 2, and root 150. Okay.
I just kept it around. And then I did
Uh-huh.
5 and root 30.
Root 3,
30.
30. Times root 5. I got it.
And then root 5 and root 6.
All right. Root 5 and root 6.
And then root 3 and root 2.
Root 3 and root 2. All right, done. Okay, so let me write all this stuff down here. So we'll see what we've got. Morgan, oh, too far. Okay, so I've got the 5 that I started with, and then root 2, another root 2. Let's see, root, oh, I don't want to do that one yet. That root 2, root 3, root 5, root 5. Okay, so now let's look for pairs. There's a pair, so 5 times 2. I don't have a pair for this 2, or for that 3. but I do for these, times 5, and then I just put those back together, root 6.
So 50 root 6.
50 root 6. I love it. Did they start us? Yeah, they wanted the positive. I like it. Nice job, Morgan. Any questions about that? You feel good about that? This is number what? 12, 13? 14. Nice. Number 14. Which means that number 14 on the exam will look like that. Okay, it won't be 5 root 600 or whatever it was. Okay. It'll be something else, but it'll be like that. Okay. What do I do now? Lily.
Okay, well, you're going to add difference to each side.
Lily says I'm solving. Oh, it says simplified. It should say solve. Okay.
So it would be 2m squared.
So we want to get the variable by itself. 2m squared is equal to 50. Yes, ma'am. Then what?
Divide each side by 2.
Let's divide each side by 2.
So it would be m squared equals 45.
Yes, that's true. Now what?
And you get the square root of each side.
Square root here, square root there.
So it's m equals 5. Plus or minus 5.
Okay. Plus or minus 5. Ha. Lily says. Right? When we take the square root of a variable, we have to give its answer as a positive and a negative. Okay? Teachers on that one, huh, Steele? All right. Duncan, help me out on this one. It says refer to the triangle below. There's the triangle below. Find the missing length correct to the nearest thousandth. So we're going to round it with 3 decimal places. Okay? So what should we do?
I did 29 squared minus 21 squared.
Where are we starting now, Duncan? What are we using? What are we working from?
Pythagorean theorem.
What is the Pythagorean theorem?
A squared plus b squared equals c squared.
All right, equals c squared. And just for the viewers at home, right? Let's go ahead and fill this in. What do we get?
Right, so we don't know the a yet.
We don't know a. All right, so I'm just going to leave a.
And the b is 21.
Yep.
And the c is 29.
All right, good. So now we've got a squared plus
441.
441.
841.
841. Nice. All right, good. And now what?
Now I guess you subtract 441 from both
Subtract
sides.
441 from both sides. Oh, not 440. Let's just say 441. All right, so now a squared is equal to
400.
400. Nice. Okay, let me scoot down here. Oh, there we go. Give ourselves a little bit more room. Now what, Duncan?
Then you take the square root of both sides.
Square root of both. Okay, square root of both sides, and a is equal to
20.
not plus or minus 20.
Plus or minus 20.
Plus or minus
no,
20.
because it's just plus 20.
Just plus 20.
Mm-hmm.
I got Duncan going all over the place. He's like plus or minus plus.
Just positive 20.
And why is it just positive 20?
Because it's a measurement.
It's a measurement, exactly. It's a triangle. So I can't have a side that's negative 20, right? Okay.
Negative distance.
Okay. Right. We don't have negative absolute value, do we? Because absolute value is a distance, and there are no negative distances. So there you go. All right. Good job, Duncan. Thank you. Yeah. Kyle.
On the exam, if we accidentally leave the plus or minus, will we get points off?
Yeah, probably a few. But remember, the problem's only worth 3 points. So that means you may lose a point for doing that. That doesn't mean I want you to do that. Okay? But each problem's only worth 3 points. There are 33 of them. 3 times 33 is 99. And I'm going to throw in a point for you. So there is bonus for this exam. And everybody gets it. All right? Okay. You know what? I'm not sure that we have enough time for the next one. Let's look at it. No, I think that's too much. All right. Let's stop here, and then we'll pick up number 17 on the next video. All right, good job.